Hello everyone, welcome to Veracious Academy. My name is Anil Kumar. I am an alumni of IIT Bombay. I have done my BTech from Mechanical Engineering. I have been teaching physics for the past decade for JEE Mains, JEE Advanced, NEET UG and other competitive exams. If you are interested to attend my sessions, please find the contact details in the description below. Let's get started with this lecture. Enjoy the video. Fine. So most important thing is we have derived for a wire at a distance A. I think this angle is theta 1 and this angle is theta 2, right? And let the charge per unit length be lambda. We have already derived for this. Yes?
Yes, sir.
So if this is I cap and this is J cap, what did we get? The resultant as E bar net is equal to
K lambda by A
K lambda by A
of sine theta 1 plus sine theta 2.
sine theta 1 plus sine theta 2 I cap plus
cos theta 1 minus cos theta 2 J.
cos theta 2 J cap. Okay.
Yes, sir.
Very important factor over here. Don't forget that the angles theta 1 and theta 2 are these angles. That means in the question, if he gives you these angles, then you will have to do 90 minus whatever is specified here.
Yes, sir.
Okay. So first thing, remember figure, and most importantly to remember what are my theta 1, theta 2. Second thing, remember the formula. Okay, very rarely I say remember the formula, but these are the situations where we have to remember these formulas, because directly we will not derive every time. We will directly basically substitute whatever is given. Okay.
Yes, sir.
So we have already done for semi-infinite wire and infinite wire.
Yes, sir.
I want you to tell me without seeing. I want you to tell me for semi-infinite wire. Okay. For semi-infinite wire. So for semi-infinite wire, there can be a confusion. So I'm drawing the diagram. So this is my lambda. This is my wire that goes to infinity beyond.
K root 2 by A.
First, tell me what are the values of theta 1 and theta 2. Looking at the figure.
First, theta 1 is 0, theta 2 is 9.
Theta 1 is 0 and theta 2 is equal to
90.
90 degree. There is no minus sign because we have already considered that in our limits in our integration.
Yes, sir.
Also. So we just have to substitute the values over here. So if I substitute these values, what will I get? I will get
K lambda A of I cap plus J.
of I cap plus J cap. Now, why I wanted to discuss this again is that whenever we come to a particular situation like this, we have to remember this figure, that along this direction also we have K lambda by A, and along that direction also we have K lambda by A. So which figure we have to remember is This is my semi-infinite wire having a charge per unit length lambda, and at a distance of A, I want the electric field at this point. So what I have to remember is that the electric field in this direction is k lambda by A, and the electric field in this direction is also k lambda by A. Correct? Yeah.
Yes, sir.
So for an infinite wire, tell me what are the values of theta 1 and theta 2?
Both are 90 degree.
Both are 90 degree. I'm not drawing the diagram. I mean, simply it will look like
The
this.
sine theta components vertical components cancel. We get root 2 k lambda by.
So E bar net is equal to,
2 k lambda.
yeah, thank you for looking at notes and confirming it. So theta 2 is, yeah,
It's 90 degrees, sir.
yeah. So let us come back. So this is k lambda by A, and I will have sin 90 plus sin 90 I cap. So basically I'll have 2 I cap, and cos 90 and cos 90 are 0, right?
Yes, sir.
Or we can also look at it as this figure implemented twice.
Yes, sir.
So for this
The
half of the
vertical
semi-infinite,
components cancel.
correct. For this half of the semi-infinite wire, I have k lambda by A in this direction and k lambda by A in this direction. And due to the upper half of the semi-infinite wire, I will have k lambda by A in the downward direction and another k lambda by A in the right side direction along I cap. Correct?
Yes, sir.
So due to the bottom wire, the two vectors along I cap j cap that I'll get is upwards and towards right if the charge per unit length is plus lambda. Is this clear?
Yes, sir.
Take it down. You have it in your notes, but take it down because we are going to solve on the basis of this right now. So one is the general case. I have to remember the diagram. Second is the semi-infinite wire. I'll again have to remember the diagram and also remember that this is for plus lambda. Third is the infrared wire. Again, I'll have to remember the diagram. So for semi-infinite wire and positive semi-infinite wire and positive charge per unit length, we have away from the wire k lambda by A perpendicular direction, k lambda by A parallel direction. Correct?
Yes, sir.
Okay. So I'll just draw that figure over here. Okay, or I'll draw the figure over here. So this is my wire. This distance is A. This angle is theta 2. And this angle is theta 1. Now using this information of semi-infinite and infinite wire, let us solve a few questions. And let us say using this formula also we will use. So in linear charge density, are we numbering the questions?
No, sir.
Okay, so let us number this one as the first question. Okay. So simply suppose I have a semi-infinite. For all our questions, remember we are taking this as I cap and this as J cap. And I want you to give the answers in terms of I cap and J cap. Okay.
Yes, sir.
So suppose this is my semi-infinite wire and the charge is plus lambda and at a distance of A, perpendicular distance of A, you need to give the resultant electric field in terms of I cap and J cap.
Yes, sir. It's the same thing as electric.
In terms of I cap and J cap. So here I'll have K lambda by A is same. But what is my I cap and J cap? So
2 I cap.
see, remember, if you look at the if you look at the semi-infinite wire that we've done just now, one I had away from it and the other fellow also I had away from it, and both are K lambda by A, right?
Yes, sir.
So this directions tell me what? Minus I cap plus J cap.
Yes, sir.
Is this clear?
Yes, sir.
So let us look at the next question. Okay. Now, suppose I have a infinite wire, semi-infinite wire. Okay, let us say I have my semi-infinite wire from here to here. So this is infinity. And at a distance of A, perpendicular distance of A, I want to find the electric field at this point.
Yes.
And the charge per unit length is lambda. So in terms of I cap and J cap, what will I get the answer as?
A lambda by A, I cap.
E bar net is equal to, so first I'll draw in the figure, one K lambda by A will be in that direction, the other K lambda by A will be in the upward direction, correct?
Yes, sir.
So therefore, this will become K lambda by A,
I cap plus J cap.
I cap plus J cap. Now, third question. Okay, so my semi-infinite wire is placed in the vertical direction, and this lambda per unit charge per unit length is lambda, and this is a positive charge, and at a distance of A, at this point P, let's say I need to find the electric field at point P in terms of I cap and J cap.
A lambda by A of minus I cap.
So one direction will be in this direction, the other fellow will be in this direction. So my E bar net is equal to K lambda by A minus I cap plus J cap, correct?
Yes, sir.
Take this down. Okay, so fourth question. So slight change over here. So we are calling it a semi-infinite wire. Okay, so let us say I have a semi-infinite wire, and it is given that the wire, it is shown basically in the figure that the semi-infinite wire is placed in the along the vertical line. Okay,
Yes, sir.
the semi-infinite wire is placed along the vertical line, and at a distance of A below the top end and a perpendicular distance of A from the wire, let's say there is a point P, find the electric field at point P. I'll solve this one. Okay. Okay.
Yes, sir.
Understand this. It's a semi-infinite wire. That means in this direction, the wire is infinity, right? Infinite. And in this direction, he has given me the sides A and A, right?
Yes, sir.
So basically from here what I can say, it is 45 degree because I'm interested in theta 1s and theta 2s.
Yes, sir.
And I know that the electric field will be in this direction and in this direction, right?
Yes, sir.
Here one small thing, the electric field due to the wire that is below the horizontal line will have away from it, that means towards right and upwards,
Yes, sir.
and the wire that is above will also have something towards right and a little bit below in the downward direction also.
Yes, sir.
That for because of that wire also the electric field will be away from it, right?
Hmm.
So we will have a little bit in the downward direction, but it is obvious from the figure because the lower wire has larger length, the magnitude in the upward direction will be greater than the magnitude in the lower direction, correct?
Yes, sir.
But in respect of all of it, because we already have the formula in our hand, we will solve it using our formula. It becomes easy, right?
Yes, sir.
So I'll write k lambda by a, and also one point from yesterday's session. It's so easy if I use lambda.
Hmm.
And if he gives me charge capital Q in any condition, first I will write it in terms of lambda, and according to that question, I'll substitute the lambda in terms of Q and length.
Yes, sir.
So this is a easier and faster way. Okay. Now tell me in this figure, what is theta 1? Theta 1 is 45 degree, right?
45 degree.
And theta 2 is obvious,
90.
90 degree, right? So k lambda by a, and we have what? Sine theta 1 plus sine theta 2. So sine of 45 degree,
Root 2 and 1 by root 2. The entire thing is 1 by root 2 plus
root 2 plus 1 I cap, plus here we will have cos 45 degree minus cos 90 j cap, right?
1. Yes, sir.
So eventually my answer for this fellow will become k lambda by a into 1 plus root 2 I cap, or root 2 plus 1, we can write it however. Okay,
Yes, sir.
plus j cap divided by root 2.
Yes, sir.
Right, I have taken the LCM, 1 by root 2 plus
Yes,
1,
sir.
1 by root 2, right?
Yes, sir.
So we can say that if I write it in terms of I cap, j cap separately, k lambda by a, let me write it the original form only. However is fine, that's not the point. Identifying along I cap and j cap is the point. Okay.
Yes, sir.
So k lambda by a, and I have a root 2 in the denominator, j cap, correct?
Yes, sir.
I want to figure out from this particular figure is that in this direction I have k lambda by a into 1 by root 2 plus 1, correct?
Yes, sir.
And in that direction it is k lambda by a root 2. Clear?
Yes, sir.
Okay.
Yes, sir.
Now let me solve another question on the basis of the first question. So now here, let us say he has given me a semi-infinite wire like this, and he wants me to find the electric field at a distance of a below the wire, and charge per unit length is given as lambda. Okay. So let us say this point is O, and we need to find the resultant electric field at point O in terms of I cap and J cap. Okay.
Yes, sir.
Right?
Yes,
All
sir.
I have to remember, so let's say this side is A and this side is A. All I have to remember is due to this infinite wire I have in this direction and in this direction, correct?
Yes, sir.
And due to this I have in the right towards right and bottom.
Yes, sir.
But overall, due to a wire like this, I have got the components away from the wire and away from the larger length of the wire, right?
Yes, sir.
So if we compare these two figures, my first thing will be away from the wire like this,
Yes, sir.
and other fellow will be away from the larger side of the wire.
Yes, sir.
And I have already calculated the story over here. So away from the wire, I have this. So that means I'll write k lambda by a into 1 by root 2 plus 1 for the downward direction
Minus I cap. Oh, sorry.
minus j cap.
Minus J cap.
And parallel to the wire is k lambda by a root, right? Parallel to the wire, I have k lambda. What I'm trying to say is that if I will remember this particular thing, okay, and use my imagination. So, like one of the problems that I was saying that usually students face is imagination also, right? So,
Yes, sir.
if we use our imagination, it becomes easy. In exam, I don't have to do it again and again.
Yes, sir.
So, my resultant electric field, E bar net, I can write it as at point O as minus k lambda by a root 2 I cap
Yes, sir.
and minus k lambda by a
Minus J. I
j
mean
cap.
J. Minus is also.
So I'll take minus common and k lambda by a root 2 common, right?
Yes,
So I'll
sir.
write it as I cap plus 1 plus root 2 j cap. Is this clear?
Yes, sir.
So here what we try to understand is that first I will only remember this figure and this formula.
Yes, sir.
I will only remember this figure, that means this is the theta 1 and theta 2 and this formula. And if a
Yes,
question
sir.
like this is given, I will redraw it according to my figure and substitute my theta 1, theta 2 values and get this kind of a figure
Yes, sir.
and then apply it for that question and get the answer for it. Are you getting my point?
Yes, sir. Yes, sir.
Suppose this particular situation is given. The only thing that I need to remember is this particular figure and formula.
Yes, sir.
I will redraw it according to my convenience, identify theta 1, theta 2, get it in terms of I cap and j cap, and substitute. Clear?
Yes, sir. Yes, sir.
Xerox. So for a semi-infinite wire, not exactly from the tip, but from somewhere in between at a distance of A, which makes an angle 45 degree, we have the electric field away from it as k lambda by A into 1 by root 2 plus 1 and parallel to it as k lambda by A into 1 by root 2, right?
Yes, sir.
Okay. So now, sixth question, right?
Yes, sir.
So now let us look at this. So we have a positive x-axis and I cap and j cap. Positive x-axis and positive y-axis. Okay.
Yes, sir.
Now Let us say a semi-infinite wire is placed like this. So this is the semi-infinite wire. Okay.
Yes, sir.
We need to find, and this makes an angle 45 degree with the, let's say, y-axis. Okay.
Yes, sir.
We need to find the electric field at a point root 2 comma 0 on the x-axis. So
Yes, sir.
so this is origin O, which is 0 comma 0, and let's say this is point A, root 2 comma 0. Find the electric field, net electric field at point A. I will solve this. Okay. See,
Yes, sir.
one of the things, the reason I have chosen this as root 2 is basically, see, we have a point, we have a semi-infinite wire. The first thing, according to my original formula, even for this formula also, is I'm interested in the length of the perpendicular line on the semi-infinite wire, right?
Yes, sir.
So if I draw a perpendicular line, I have a right angle triangle.
Yes, sir.
And in this question, I have given root 2 comma 0, so that this becomes root 2.
Yes, sir.
And in right angle triangle, the hypotenuse is root 2 implies that this length is 1 and this length is also 1.
Yes, sir.
You're getting my?
Yes, sir.
So these things we will figure it out. We'll have to figure it out in the exam only when such a question comes. One obvious and mandatory thing that we're going to do is draw a perpendicular line. That is for sure.
Yes, sir.
Because we need that length.
Hmm.
After that, we need the angles.
Yes, sir.
Also, here I have given root 2 comma 0 so that it becomes 45 degree, right? 1 and 1.
Yes, sir.
Also, here in this figure, I want to say about this is one of my angles. Maybe theta 1, maybe theta 2, that's our wish. But this is the angle, not the other one.
Sir, it will be 45 only because we have 190.
Correct. This is a isosceles right angle triangle.
Yes, sir.
Right. So my isosceles right angle triangle over here comes like this. Right. This is one. This is one. This is my 90 degree. That's why this fellow became root 2. So obviously this angle becomes 45 degree, right?
Yes, sir.
But I am saying, I told you that we have to remember that the angles theta 1 and theta 2 are these angles and not the other angles.
Yes, sir.
So in the diagram, what are my theta 1? How will my theta 1 and theta 2 look like? This is one of the angles, not the other one. So suppose in terms of 60 degree, 30 degree, it will matter. In 45 degree, it will not matter.
Yes, sir.
But suppose that angle is 30 degree. So it is important for us to identify. So the angle subtended by my wire at the point is the angle that we are taking.
Yes, sir.
Understood? So
Yes,
the
sir.
angle subtended by my wire at that point is this angle and not the other side, other angle. Okay.
Yes, sir.
Now, by achieving this 45 degree story and all, what I eventually tried to do is that, so from this figure I can, without,
Join to the other. Oh, that is infinite.
that
Yes,
is, this side it is going to be infinite. By drawing this figure and getting this 45 degree and all this story, what I am figuring out is that my electric field away from the wire is what? Just now we solved k lambda by a 1 by root 2 plus 1.
Yes, sir.
Correct?
Yes, sir.
K lambda by A to 1 by root 2 plus 1. And my electric field in this direction is what? K lambda by A root 2.
Yes, sir.
I will draw this again over here for clarity. This is my wire. This is origin. This is the point A. Okay, this is my point A. Now, draw a perpendicular. I found out this is 1. And because the hypotenuse is root 2 and this is 1, automatically this also became 1. By telling me that this angle is 45 degree. By telling me this is related to the previous problem that I have solved.
Yes, sir.
Next, why is the previous problem useful for this problem? Because I already know the values of the electric field away from it is going to be K lambda by A into 1 by root 2 plus 1. And another fellow is K lambda by A root 2.
Yes, sir.
Why I am mentioning this is that the question in the formula over here, wire is vertical.
Mm.
If I will draw the figure, identify theta 1, theta 2, and again go back to this, I will be confused with my I cap, J cap again. Because there the
Yes,
wire
sir.
is vertical, accordingly my I cap, J cap is written like that.
Yes, sir.
Here I have to figure out my own I cap, J cap story.
Yes, sir.
So when an average student looks at this question, he will give up.
Yes,
He
sir.
will think this is complicated. So in the solution also, even after telling the solution also, why will the average student feel difficulty or feel a little uncomfortable situation feeling is because there is imagination included in this.
Mm.
Now the same wire, if I will rotate it anywhere along any axis, same wire, same situation, same 45-degree situation, we take it anywhere, rotate it, or take it anywhere. Okay.
Yes, sir.
Till the thing that we have to remember is, as long as my 45-degree and 90-degree are fulfilled, away from the wire is K lambda by A into 1 by root 2. And parallel to the wire in that direction, away from the larger side, is K lambda by A root. If I remember these two, I will then newly figure out my I caps and is.
Yes, sir.
Now understand. So did you understand this figure?
Yes, sir.
Now let me finish off in terms of I cap, J cap of this question. Okay, so this is my I cap and this is J cap, and everywhere we know we have 45 degrees. Correct?
Yes, sir.
So in the question, if in the exam, if that question is given, first I will draw this figure for my comfort.
Mm.
Then I will write this Ex is equal to, due to this magnitude, which is K lambda by A into 1 by root 2 plus 1. I will have cos 45 I cap. Correct?
Yes, sir.
And this is also 45-degree, by the way. Everything is 45-degree in this question, right?
Yes, sir.
And due to this, along this direction, I will have minus K lambda by A root 2. You can say cos 45 or sin 45. That's your wish because it's the same. Again, this is also I cap.
Yes, sir.
Correct?
Yes, sir.
Cos 45. So that means along my x-axis, Ex bar along I cap, what am I getting? I will take this k lambda by a story common. Okay.
Yes, sir.
1 by root 2 plus 1 into 1 by root 2 is there due to cos 40
Mm.
minus 1 by root 2 is already there into 1 by root 2 is again there due to cos 40.
Yes, sir.
Whole bracket I cap. Correct?
Yes, sir.
If you see this 1 by root 2 and this 1 by root 2 is going to get cancelled.
Yes, sir.
I'll get it as 1.
Yes, sir.
I'll get it as 1 by root 2. This 1 by root 2 will cancel with this entire term and I'll get it as 1 by root 2.
1 by root 2.
So I'll have k lambda by a root 2 I cap. Correct?
Yes, sir.
What is my EY bar? Again, both are towards downward, so we will have plus sign.
Yes, sir.
So first is k lambda by a into 1 by root 2 plus 1. You can say
1 by root.
we have to take sine 45. Correct? For this component. Plus, for this fellow, k lambda by a root 2, again sine 45. Entire thing j cap.
Yes, sir.
And it will be plus sign because both components are adding each other. Okay?
Yes, sir.
So here, I'll take k lambda by a common. I cap also I'll take it outside. J cap also I'll take it outside. Right?
Yes, sir.
And one important thing is this entire thing is negative because it is downward.
Mm.
Okay, minus J cap for everything.
Yes, sir.
Now, I have 1 by root 2. Yeah.
There are sign. Okay.
Yeah. Okay.
Yes, sir.
So I have 1 by root 2 plus 1 into sine 45 is 1 by root 2 plus I have 1 by root 2 into 1 by root 2, right?
Yes, sir.
Whole thing J cap.
Yes, sir.
So here we have 1 by 2 plus 1 by 2 is 1 plus 1 by root 2.
2 by root. Yes, sir. No.
So I'll write the final answer. K lambda by A minus, by the way, minus sign is there. Okay.
Yes,
Minus K lambda by A. This 1 by root 2 into 1 by root 2 is half and this is also half. So that becomes 1 plus 1 by root 2. And I have J cap. Is this clear?
Yes, sir.
So for that particular question along I cap J cap, my final answer, I will get it as my E bar net at the point A can be written as K lambda by A. I will take common for everything, right? For both I cap and J cap. Okay.
Yes, sir.
Let us take K lambda by A common. I have I cap by root 2 along x axis.
Mm.
The first term is I cap by root 2. And for second term, I have minus 1 plus 1 by root 2 J cap. Right?
Yes, sir.
Minus of 1 plus 1 by root 2 J cap. Is this clear?
Yes, sir.
I'll just explain it once again. Nothing much to, we didn't do any big thing over here. The only thing that we did was where? Here?
Yeah.
This is I cap by root 2. Okay? And this is J. Okay? See, I'll explain again. This might look like a big solution, but my explanation was longer. Actually, when you practice it for 2-3 times, and if you get the imagination part that I'm trying to explain, Then you will solve this within, let's say, 90 seconds. Okay.
Yes.
So simply, what is the question? Semi-infinite wire from origin at an angle 45 degree with x-axis, y-axis, right?
Yes,
At a
sir.
point of root 2 comma 0, find A. As soon as I look at root 2 and I will see this 45 degree, I will first have to come to the conclusion that this fellow has this distance as 1 and this perpendicular distance as 1. Only in that case it can be
Yes,
root
sir.
2 comma 0. Either which way, whichever point he gives, one compulsory thing that I have to do is draw a perpendicular and find its length, because I want the length of the perpendicular line.
Yes, sir.
After that is done, once I know this is one, I know this fellow is giving me symmetric question. That means he wants me to utilize my imagination along with vectors.
Yes, sir.
So as soon as I get to know that this is 45 degree and the other fellow will be 90 degree, I have to remember which thing from the previous question, that away from it I will have k lambda by a into 1 plus 1 by root 2. And also away from the larger side, I will have k lambda by a root 2.
Yes, sir.
For better understanding, I draw the figure over here. So in this direction, I have k lambda by a into 1 plus 1 by root 2, which I am saying away from it in the perpendicular direction, right?
Yes, sir.
This is my wire. And away from it in the parallel direction is again k lambda by a root. Fine?
Yes, sir.
Once this is done, everything is 45 degree. Now from here I have to get in terms of my I cap j cap for this question, because he has given this is I cap, that is j cap, right? So this becomes k lambda by a into 1 by root 2 plus 1 cos 45 I cap. K lambda by a into 1 plus 1 by root 2 cos 45 I cap. And k lambda by a root 2 cos 45 minus I cap. K lambda by a root 2 cos 45 minus I cap. Clear?
Yes, sir.
So solving that is not a big deal. Sometimes we might do some mistake or something, but solving that is not the bigger issue over here. Imagination and then converting my given geometry in terms of my I cap, J cap according to the question is important. Okay.
Yes, sir.
Similarly, these two will have a component downward direction, so positive sign will come in between. K lambda by a 1 by root 2 plus 1 sine 45 towards minus j cap, minus sign. K lambda by a root 2 sine 45 again minus sign sine 45 j cap.
Yes, sir.
Again solving this, I got it. Now I
Yes,
just
sir.
have to write it in terms of resultant vector at point A along I cap j cap can be written as k lambda by a I cap by root 2 minus of 1 plus 1 by root 2 j cap. Is this clear?
Yes, sir.
Xerox.
Hi guys, I hope you enjoyed this session. If you think this video was useful, don't forget to like, share and subscribe to my channel. Also, I'll be waiting for your comments in the comment section. See you in the next video.